Hello, this is Mathcast 3. Today's date is 11/14/24. The intended audience is grade 4. Our learning objective is recognize line of symmetry for given two-dimensional figures, identify line symmetric figures, and draw lines of symmetry. And this is created by Xander Gage. Let's get going with some vocab. So we have right here, we have our symmetry. We're going to start with that one. So there's multiple versions of symmetry. We're going to go over 3 of them. So our first one is line symmetry. So line symmetry is a figure that has line symmetry if the figure can be mapped onto itself by a reflection line. So you see how they have this line right here going up the middle? So if you were to fold that in half, it would be the same thing. The triangles would line up perfectly. Like, pretend you had a piece of paper and you had a triangle on it. If you fold that paper in half, the two triangles that were created would line up beautifully with each other. So our next one's going to be point symmetry. So a figure has point symmetry if the map figure map onto itself by rotating the figure 180 degrees about a center point. This means it looks the same upside down. So this N here, if you flipped it around 180 degrees, it'd be the same thing. Same exact shape. Our next one is rotational symmetry. A figure has rotational symmetry if the figure has been mapped onto itself by rotating the figure less than 160 degrees about the center point. Think of a pinwheel. Okay, difference between point symmetry and rotational symmetry is that this is a little bit more than 180 degrees. You can flip this any direction and it'd be the same thing. Your center point would be right there, right in the middle of the sun. That's what it looks like to me, at least. So you could rotate that anything less than 160 degrees, so even 180 degrees, but you could rotate it 359 degrees and it'd be the same exact picture. Now we're going to move on to 2D shapes or two-dimensional shapes. So 2D shapes are flat shapes in which only have 2 dimensions, length and width. Some examples of common 2D shapes names are triangles, rectangles, pentagons, hexagons, heptagons, octagons, nonagons, decagons, and circles. So difference though with circles is circles have a radius and a diameter and a circumference. So this is circumference, which is d pi or pi d. The diameter is 2r, and the radius is 1/2 diameter. So say your diameter for a circle is 12, d equals 12, your radius is 6. So now this example says half of each figure has been drawn. Use a line of symmetry represented by the dashed line to complete the figure. So the best way I can teach you to do this is you just count how many squares over and down you have on each side, or this side is your width and this is your length, or it could be the other way around, length and width, doesn't matter. So you have 1, 2, 3 over, same as here, 1, 2, 3, and then you got to go down 6. 1, 2, 3, 4, 5, 6 over 3. That completes that shape. So now if you fold it about that line, same thing. Let's go over to B now. So this one's different. You gotta just do it per box. So you're gonna go down 4. 1, 2, 3, 4 over 3. 1, 2, 3. Down 2. 1, 2 over 3. 1, 2, 3. You're gonna go up 1. You're gonna go over 1. And then you're gonna go back down 3. So now on that dashed line there, if you were to fold it, it'd be roughly the same shape. I can't draw, but close enough. Now for this triangle down here, we're going to have to do some diagonal ones. So you got to go down 2 over 3. So right there's the point. Connect that line. And then we're going to go over down to here and connect it. They're roughly the same. I, once again, can't draw, but if you were to fold those over, they'd be the same. So for this last shape here, we have Mike the Mouse in the middle. So we got to go down 1 over 3. So down 1, 1, 2, 3 over 3, connect. We got to go down 4, 1, 2, 3, 4, and then the same thing, down 1 over 3. Now we've trapped Mike the Mouse in our shape here, and if we were to fold it across that line, you'd have the same shape. All right, now we're going to do some more examples. So this one's asking, is the line of is the line drawn a line of symmetry? Circle our choice. So we have 3 options. So let's look at our flag for the first one. So does that look like if you were to fold that over on itself, would it line up? Yes, it would. Look at our square for the next part. If you fold that over, would it line up? If you fold this corner over to this corner, would it line up? Yes, it would. Look at our circle here. So for a circle, there's only 2 lines, a couple lines of symmetry, but this is not one of them. This is not one of them. Now we're going to go to our bottom example here. Draw as many lines of symmetry as you can find in the figure below. So the easiest one is you go straight down the middle. So now you fold it in half, you got the same one. The second easiest one is you do this, whoop, right across the middle again. So now you can fold that and it's the same thing. You can do this one too. You can go whoop, straight across, fold that in half, same thing. Same with this one, whoop, fold it in half. And that says all the lines of symmetry that this shape has. All right, our final round of examples. Close it out here. So the first one asks, circle the figures that have the correct line of symmetry. Let's look at A. So if you fold that in half, would it fit together? Yes, it would. What about this shape here? This pentagon. Nope, it wouldn't. The line of symmetry would have to be this one. That won't line up. So nope, that one's not it. What about C, the heart? Fold that in half. Yep. This one. Look, macaroni looking shape, that doesn't look right. The line of symmetry would have to be right there, and it's not. So that's not one of them. So we're going to go fly. Those are not our options. Now, it says down here, it says find and draw all the lines of symmetries for the following figures. Write the number of lines of symmetry that you found in the space below. So, let's switch our color up here. Let's do blue. So now we can do, let's just do A, B, C. Let's just stick with those, and then we'll call it even. So if we look at this shape here, this trapezoid, if we only have one line of symmetry right there, because if you draw it, if you do this one, we'll do the pink line. If you go like this, straight across, this somewhat dotted pink line, it's not going to line up because the bottom of it is wider than the top of it. So in this one, this trapezoid, we only have one line of symmetry. This square, we should know. We just saw in the last example. We got one that goes this way. We got one that goes this way. We got one that goes up. We got one that goes across. So how many lines did we just draw there? So now we have 4 lines of symmetry for the square. And this shape here, the stop sign. So we can do this one straight across. We can do this one straight across, straight across. That's 4 right now. We have 4 of those. Can we draw any more? I don't think so. We got 4 lines of symmetry. We'll do D as a little added bonus, because that's up here, and guess what? They drew the wrong one up there, so we're going to show them what's done. So you're going to draw straight down, and that's your line of symmetry. You got 1 line of symmetry for the pentagon. And that'll be all. Thank you for watching. The MathCast resources have been posted. This was created by Xander Gage. Have a wonderful day.